Hello friends, this video on Quadrilaterals part 9 is brought to you by examfear.com. No more fear from exam. So based on all the basics that we have learned so far on polygon, on diagonals, on quadrilaterals and their properties, let us try to solve some of the questions. Question number 1. How many diagonals does each of the following have? A convex quadrilateral. So any convex quadrilateral, how would it look like? Maybe something like this. A convex quadrilateral. Quadrilateral anyways will have 4 sides, and since it is a convex quadrilateral, it would be a bulging quadrilateral where all the internal angles are less than 180 degrees. Now here, how many diagonals can we draw? This is one diagonal and this is another diagonal. So maximum we can draw 2 diagonals. Now when you talk about a regular hexagon, a regular hexagon is one with 6 sides. And regular means the sides are equal and the angles are also equal. So values of the length of all these sides are equal and also the internal angles are equal. So in this case, how many diagonals can we draw? So we can actually draw many diagonals. Let's see. In fact, let's name this. Let's call this as A, B, C, D, E, F. Now from point A, let us try to join all the non-consecutive vertices because they are the diagonals. So from A, we could draw 3 diagonals. From B, let us try to draw the diagonals. We could draw 1, 2 and 3. So from B also we could draw 3 diagonals. From C, now C is already connected to A, C is not connected to F. So let's draw this. Now C is also not connected to E. So from C, we could draw how many diagonals? We could draw 3 diagonals. So basically, let's try writing also. So for A, we could draw 3 diagonals. For B, again, we could draw 3 diagonals. For C, we could draw 2 diagonals. What about D? So you see, D is already connected to B. D is also connected to A, but D is not connected to F. So from D to F, we can draw only 1 diagonal. So for D, we can draw 1 diagonal. For E, from E to C already connected, E to B already connected, E to A already connected. So from E, we do not need to draw any further diagonals. So that means these are the total number of diagonals that we can have in a regular hexagon. So this comes out to be 9. When you look at a triangle has 3 sides. So let's name this A, B and C. So here we will actually have 0 diagonals. You know why? Because when you diagonal is that line segment which joins 2 non-consecutive vertices. But here you don't have any non-consecutive vertices. So for A, both B and C are consecutive vertex. Similarly for B, both A and C are consecutive vertices. For C, again, A and B are consecutive vertices. So we really do not have any non-consecutive vertices to be connected by a diagonal. Therefore, the number of diagonals in a triangle is 0. Question number 2. What is a regular polygon? State the name of a regular polygon of 3 sides, 4 sides and 6 sides. So as mentioned before, so in a regular polygon, all the sides and all the angles would be equal. And obviously it has to be a polygon, that is, it has to be a simple closed curve made up of only line segments. Now, what would we call a polygon with 3 sides? So a polygon with 3 sides would be a triangle. 3 means tri. A polygon with 4 sides would be a quadrilateral. And a polygon with 6 sides would be a hexagon. Now, do you think I missed out something? The question asked the name of a regular polygon. Now, these would be just polygons. So, quadrilateral is a polygon with 4 sides, but it is not a regular polygon because all the quadrilaterals, they do not have their all sides and all angles equal. So that means which is that type of quadrilateral which has all sides and all angles equal? Yes, absolutely. That is a square. So square would be a regular polygon with 4 sides. Similarly, which is that triangle which has all sides and all angles equal? Yes, absolutely. That is equilateral triangle. And when we talk about hexagon, what would be that hexagon? That would be nothing but a regular hexagon. So the moment we say regular hexagon, that would mean that all the sides of the hexagon are equal and therefore all their angles are also equal. Question number 3. Find x. Now here, what is this polygon? Which type of polygon? It has 4 sides. 1, 2, 3, 4. So this is a quadrilateral. And what do we know? This x is one of the interior angles of the quadrilateral. Now we know that the sum of the interior angles is equal to how much? Sum of interior angles of a quadrilateral is equal to 360 degrees. Now basically the formula is n minus 2 into 180 degrees, but here n would be 4. So therefore we would get sum of the interior angles 360 degree. So here what are the interior angles? 50 plus 130 plus 120 plus x is equal to 360 degrees. Therefore we can say this entire value would be 300 degrees plus x is equal to 360 degrees. Therefore x will be equal to 360 degrees minus 300 degrees, which would be nothing but 60 degrees. Therefore the value of x is 60 degrees. Question number 4. Again find x. So here if you see, this is again a quadrilateral. Therefore the angle sum of interior angle of the quadrilateral, the interior angle sum here also would be equal to 360 degree. So we have 70 degree plus 60 degree plus how much would be this angle? So if this is 90 degrees, this is also 90 degree, because the sum of these two angles is a straight line which is 180 degree. So this would be 90 degrees plus x is equal to 360 degrees. So this entire value is 220 degree plus x is equal to 360 degree, or we can say x is equal to 360 degree minus 220 degree, which is equal to 140 degrees. So that's the value of x. Thank you. Please visit examfear.com for free quality education. You can learn with a simple 4-step learning process wherein you can watch video lessons, you can ask your questions, you can refer notes, and you can take a free online test. We have content for class 6 to 12 on physics, chemistry, mathematics, and biology along with practical videos. So please subscribe to our channel for daily updates. Thank you.